Okay, so in this part of the lesson, I'm going to go over the intermediate value theorem. Now, this is very important, especially if you're in AP calculus, because there's usually going to be a free response problem that, is going to, involve this, and there's usually a couple multiple choice problems that, involve it as well. Now, let's first go over it formally, then we'll kind of go through like the basic idea behind the concepts of it. So it says that if a function is continuous on the closed interval a, b, where f of a is not equal to f of b and k is any number between f of a and f of b, then there's at least one number c in a, b such that f of c is equal to k. Okay, so at first, this can seem a little intimidating and confusing, but let me go through like a picture of what this is saying, and you're actually going to see it's actually not that difficult. It's actually pretty simple. So let's just basically go about it, and draw exactly what it's saying. So let's draw our x, y axes. And we're looking at the interval a to b. So we're talking about our x value. So let's pick, an a and b value like this, from left to right. And we're going to draw a function, and we're just going to make some arbitrary function as long as the endpoints of the function are not equal. Remember, f of a and f of b can't be equal, and these are the y values of the function. So let's say I just did something, let's see if I drew something like, maybe it goes like that. Here's my function f. So it's continuous on this interval. And now we're talking about, and the endpoints are not equal. And then now we have to show that k is any number between f of a and f of b. So remember, k, we're talking about the y values. So let's first draw what we mean by f of a and f of b. So a would be, we're talking about, the value of on the graph where x is equal to a, and we're talking about this point right here, roughly speaking. So we would say that's a f of a. And f of b would be, the y value on the graph where x is equal to b. So it'll be something like over here. Say that's b f of b. Now, let's also now draw horizontal lines on the y-axis that represent f of a and f of b to kind of get a very clear sense of what the k value looks like. So if we draw a horizontal line through f of a, this line represents the line y equals f of a. We do that same sort of thing for b, or f of b. We draw a horizontal line cutting across the graph where this horizontal line represents the equation y equals f of b. Now, if we're talking about a k value between f of a and f of b, all this is saying is that we just pick a value between here and here. Any value. It could be down here, here, or whatever. Let's say this values are going to be this line. That's going to be our y equals k. Now, what this is saying is that this graph must have an x value, in this case c, or c value, which represents our x values, a c value between a and b, where that if you plug c into the function, the graph would give you the k value. In other words, if we went about and let's draw a horizontal line that represents k, and let's see where f of k would be. And it would be this point right here. Now if you draw the a vertical line going downwards, we can see that the x value would be right here. We'll say this is our c value, we say. So this point here we represent as ck. Or you can say this is the same as, CF of C. So again, this theorem is just saying that there has to be a value of x between a and b such that you'll get a value of y equal to k in this interval. A way to think about this in like a real life example, think about like, maybe like when you're, let's say you're like, when you're 3 years old, let's say your age is 3, and when your height is, 3 feet, you're 3 feet tall when you're age 3. And then, when you're age, let's say 20, you happen to be 6 feet tall. So you're 3 years old, and you're 3 feet tall, and when you're 20 years old, you're 6 feet tall. This is like saying, like, well, there has to be an age. Let's say when were you 5 feet tall? It's like when, at what time were you 5 feet tall? Well, you had to have been 5 feet tall between ages 3 and 20. There's no, we know that, your height is continuous. You're gonna have to take every value between 3 feet and 6 feet from ages 3 to 20. So just think of this as like these are like your x values and these are like your y values. That's all this is kind of saying. This is just like a fancy way of, showing it mathematically. But anyways, let's go through an example problem, because this is make this a lot easier to understand. So for our practice problem, it says we're going to use the intermediate value theorem to determine the value of c that yields the indicated value on the given interval. So our function is going to be equal to x squared plus x minus 1, and we're dealing with the interval 0 to 5, and f of c equals 11. So essentially, we want to find a c value between 0 and 5, where if you plugged in that c value into this equation, you're going to get 11 for the y value. Now, when you're going to be working with these types of problems, it's really important that you check the conditions and show that you check the conditions, especially on your AP exam, because they'll take away points if you don't. So the conditions we really want to make sure we check is that we can say it's continuous and that f of a and f of b are not equal to each other. So it's the continuity condition. We can say it's continuous because this is a polynomial, and polynomials are going to be continuous on given intervals. So f of x is continuous on 0, 5. So we can say since it is a polynomial. And now we just show that f of a and f of b are not equal. So f of a would be f of 0, and f of b would be like f of 5. So we plug 0 into here, we would get -1. Plug 5 into here, you would get 25 plus 5 minus 1, you would get 29. And so then you can say that f of a and f of b are not equal, since -1 is not equal to 29. Okay, now we go ahead and we figure out the c value for this equation that will give you a y value of 11. So what you want to do is basically, set this up as is making it like you're solving a polynomial. So we're going to go and make x squared plus x minus 11 equal to 11. And then let's solve for the zeros. Let's use our algebra. Add or subtract 11, we'll get x squared plus x minus 12 equals 0. Factor this. So the x plus 4 times x minus 3 equal to 0. So then we have two possibilities, x plus 4 equals 0, and then x minus 3 equals 0. So we could say it's, x equals -4, or it could be x equals 3. Now this problem, we're talking about the interval 0 to 5, so it's not going to be -4 because -4 is not in this interval, so we don't care about this one. So we care about this. So then we can say that f of c, or f of 3, would equal 11, so c equals 3. So that's basically our answer, but let's actually draw a picture of what this is doing, because you want to again make sense of this in a conceptual way, so you don't feel like you're just memorizing some process. So let's start at these points. We know that at 0 the graph is at -1. So let's draw like an xy axis. So let's say this is 0, -1. We know the point 0, -1 lies on the graph. And we know the point 5, 29 lies on the graph. And this is not drawn to scale. Now, what this is saying is that there has to be a c value between here and here such that if you plug in that c value into the equation, you're going to get 11. And that's because, see, 11 is going to be between this point and this point on the y-axis. Let's say that this is 11, like y equals 11. So again, in order for this point to connect to this point, because we've already shown it has to be continuous, it has to go through the point, or has to go through the line y equals 11 somewhere between 0 and 5. So that's all that's saying. So I always recommend having a picture just to reinforce what you're doing and to make sure you understand it as well.